What can I help you with?
I had a question about percent abundance of isotopes. If you could go over one of those problems, and then there's a question on the quiz. They're both questions on the quiz that I didn't get. Question number 3. It says 200 Hg contains, so an atom of isotope contains 200 Hg, and then it asks, to pick the right combination of protons, neutrons, and electrons, or just protons and neutrons, I believe.
Okay, so
I guess really what I'm asking,
I don't know what the question actually asks, but I'll just give you an idea of what you should know.
Okay. Yeah. So the question is, what does the 200?
So it's probably this, something along the lines of that, and what's up?
It's the 200 is a superscript before the Hg.
Right. Oh, well, that's all right. These mean the same thing.
They do. Okay.
Yep, they mean exactly the same thing. And there's also, you can write it this way. So when you write it this way, you're writing XAZ. When you write it this way, you're writing XA. And when you're writing it this way, you're writing XA. So A is the number on the top, or it's the number afterwards. 80 is the number on the bottom. And you'll notice the smaller number always goes on the bottom.
Okay.
The Z, the number on the bottom, is the number of protons.
This is sounding familiar.
The A is the number of protons plus the number of neutrons. And the number of neutrons is equal to A minus Z. And X is the symbol.
Okay, thank you.
You bet.
Yeah, the next would just be percent abundance.
So let's look up a problem in the textbook. So, do you see this one right here in the book? Calculate an atomic weight from isotope abundance.
What page is that?
64. So they give you the mass of each isotope and the percent of each isotope. And they say calculate the atomic weight of bromine. Okay. So to do that, you use the following formula. AW, which stands for atomic weight, is equal to the sum of the mass of the isotope times the percent abundance of the isotope over 100. So that's the formula. And here's how you use the formula. In this case, it's going to be the mass of bromine 79 times the percent abundance of bromine 79, whoops, 79 should go in front, over 100. And that's not all, because there's another isotope. So the mass of bromine 81 times the percent abundance of bromine 81 over 100. They give us that the mass of bromine 79 is 78.918338 U. And the reason I call it bromine 79 is you can see that the mass is really close to 79,
Right.
which means it has 79 protons and neutrons. The percent abundance is 50.69, and then you put that over 100. And if you want, you can say 50.69% over 100%. That'd be fine, but you don't need the percentages. I don't usually put those in. And the mass of the other bromine is 80.91, 6291 U, and it's 49.31 over 100. So you can see that we basically have 80 times 50 over 100. So the answer for the first part should be half of 79, which is about 40, right? So I'm going to plug these into my calculator and see what I get. So for the first one, I get a ridiculous number, 400. I know it's not 400. So I did something wrong. And on second try, I get 40.00370553 U. Now this has a whole bunch of significant figures, but 50.69 only has 4. So this would be rounded here if I were done, but I'm not done. So the arrow tells you where I would round.
Right. So the 0 would stay the same.
Yeah, but I'm not going to round yet because I'm not done.
Oh, that's right.
So here I've got 39.89982309. And if this one were done, I would also round right there.
Right.
So when we add these two numbers together, we get 79.90352862 U. And here, since this is good to 2 places after the decimal, and this is good to 2 places after the decimal, I round this to 2 places after the decimal because I use the rule for rounding for addition. Addition is you look at precision.
Right.
So the answer is 79.90 U. And this is the kind of work I would expect to see for this problem, except I wouldn't expect to see this. This is not necessary, but in my opinion, it certainly helps you to guide you through what you're doing.
Yeah, it's kind of like a little map for you to follow. I think it does help.
Yeah, it's a very methodical way of doing it, step by step. Write out the general formula, write out the formula using symbols for your particular isotopes, put in those particular numbers that you have, and then go to work. I wouldn't even expect this part to be in there. I'd expect this, and the correct answer with the correct number of significant figures. But if you put the other stuff in there, that'd be fine too.
Okay.
So that's how you calculate.
Well, I'm certainly not going to erase it.
Yeah, this is how you calculate the atomic weight of an element. And if you have 3 isotopes, how many things are you going to have here? 1,
3.
2.
And so this is, we've 3, yeah.
3 of them. And if you have 5
so-
isotopes, you'll have 5 of those.
Okay.
So naturally,
And then,
I found the element that has the largest number of isotopes and gave you that information. I think it's 13 isotopes. So I just wanted you to do a lot of busy work. I'm kidding.
and then after you find the atomic weights, then you need to use the percent abundance formula to get the percent abundance of each one, and that is the
No,
part-
that's different. You're talking about a different type of problem. So let's say that you're giving that boron has an atomic weight of 10.81 AMU. And you know that there's a boron 10 and there's a boron 11. What's the percentage for each? What's the percentage? So the way you do a problem like this is you say that the atomic weight is equal to the sum of the mass of boron 10 times X, where X is equal to the percent abundance of boron 10 over 100. And then, oops, I need to get rid of this. I'm going to start this over. The atomic weight is the sum of the mass of the isotope times the percent abundance over 100 for the isotope. So now I would write the mass of boron 10 times X, where X represents that. Or I could do this, maybe this would be clear if I wrote the mass of boron 10 times the percent abundance of boron 10 over 100 plus the mass of boron 11 times the percent abundance of boron 11 over 100. Now here we put numbers in the last problem, but we don't have those numbers. So I'm going to say the atomic weight is the mass of boron 10 times X plus the mass of boron 11 times Y. So here, is it clear that X is the percent abundance of boron 10 over 100? And Y is the percent abundance of boron 11 over 100?
Yes.
Because you can see
This
a
is-
direct correlation. Hey, I don't have this anymore. I now have X. Well, that's because that's X.
Right. So that's why I thought, because the question in the quiz, it gave me the exact, pretty much the exact type of information that you just, that the question on 64 in the book used. And then it asked you to find the percent abundance of each isotope.
Yeah, and for that one, you don't really need a calculation.
Okay.
I mean, take a look at this answer here. It's 10.81. Do you have more 10 or more 11?
More 11.
More 11. So if your choices are 80%, 20%, 50%, 50%, or 20%, 80%, which one are you going to choose? This is A, this is B, this is C. Which one are you going to choose?
C.
Yeah, this is the only one that fits. What if you're given another choice? You're given a D and it's 1% and 99%. That's certainly more B, isn't it?
Yeah.
But with that percentage, don't you expect it to be really close to 11 for a mass?
Yeah.
Really close, not 10.8,
Right.
like 10.99 or something, right?
Uh-huh.
And then suppose you're given the E, 99% and 1%. It's still going to be C. And I think on the quiz, you can actually do that with that problem. Now, we can actually show how it works out by all of this down below. Now, I want you to think about if the percentages are 80 and 20, then this one here is going to be the 20. 20 over 100 is 0.2, right?
Mm-hmm.
And this one's going to be 80 over 100, which is 0.8. The point I'm trying to make is that when you do this work, X and Y, when you add them together, they equal 1. This is X, this is Y, if this is the case. What does this and this add up to?
100 or 1?
No, what does this and this add up to? 1. So percent abundance of 1 plus percent abundance of 2 is equal to 100%. Percent abundance of 1 divided by 100 plus percent abundance of 2 divided by 100 is going to equal 1.
Okay.
So we have X plus Y is equal to 1, or Y is equal to 1 minus X. So what do we do with that? We say that the atomic weight is, I'm going to go ahead and put the mass of boron 10 times X plus the mass of boron 11 times not Y, but 1 minus X. So here you have one equation and you just solve for X. A little bit of algebra and you're home free. And you might be asking, so I never gave you the mass of boron 10. What are you going to use? Let me ask you this. We just did this. How many protons does boron 10 have? Feel free to look at a periodic table.
It would have to have 10, right?
No. How many protons does it have?
Protons. Oh, 5.
Right. Okay, if it's got 5 protons and it's got 10 things in the nucleus, 5 of them are protons. What are the other 5?
Neutrons.
Neutrons. So you got 5 neutrons and you got 5 protons. How much does a proton weigh?
Not a lot.
1.00 AMU.
1.00 AMU.
Not a hard number to remember. 3 zig figs, 1.00. How much does a neutron weigh? .00 AMU. This thing also has 5 electrons. How much does an electron weigh? And the answer is like 0.0002 AMU. In other words, a negligible amount. So how much does this thing weigh if it's got 5 neutrons, each weighing 1.00, 5 protons, each weighing 1.00, and 5 electrons? 10.0.
Just over 10, yeah.
Well, you just say 10.
10.
How much do 11? How much does boron 11 weigh?
11.
11. How much does chlorine 37 weigh?
37.
37.0. How much does chlorine 35 weigh?
35.0 AMU.
Right. And so we get 3 significant figures because we're using 1.00 as the multiplier, which has 3 zig figs.
Okay.
So if you plug those numbers in, and we're not going to do that quite yet. So we get the atomic weight is the mass of boron 10 times X plus the mass of boron 11 times 1 minus X. So do you see how I'm abbreviating mass of boron 10?
Yeah.
Now I'm going to say that the atomic weight is the mass of boron 10 times X plus the mass of boron 11 times 1 plus the mass of boron 11 times negative X. So what I've done here is I've distributed this multiplier against 1 and against negative X. If you have 1, or if you have 2 times 3 plus 4, that's equal to 2 times 3 plus 2 times 4. So we distribute the 2 into the parentheses. And you know that you should be able to tell that this works because 3 plus 4 is 7. 7 times 2 is 14, right? 2 times 3 is 6. 2 times 4 is 8. What's 6 plus 8? 14.
14.
So now what I can do is I can say that the atomic weight minus the mass of boron 11. And here, what is this times 1 equal to?
That.
That. So I'm not going to bring the 1 over. Is equal to the mass of boron 10 X. And I'm going to put minus boron 11 times X. I don't like the X inside the parentheses, so I pulled it out. Are you with me there?
Mm-hmm.
So now I get the atomic weight is the atomic weight minus the mass of boron 11. So I don't think I need parentheses anymore. Is equal to X times the mass of boron 10 minus the mass of boron 11. So now I've taken the X out of both of these. And finally, I get X is equal to the atomic weight minus the mass of 11 over the mass of 10 minus the mass of 11. So now I just plug numbers in. The atomic weight is 10.8 U, 10.81 U. The mass of boron 11 is 11.00 or 11.0 U, excuse me. And here we have 10.0 U minus 11.0 U is equal to X. And you end up getting on the top, you get 0.19 negative U over negative 1.0 U is equal to X. And so you end up getting 0.19 is equal to X.
And then that correlates with what part again?
Well, that correlates with this right here. I'm circling it. So then I'm going to write this over here. You say that the percent abundance of boron 10 divided by 100 is now equal to 0.19.
Which is really close to 20%.
So you multiply each side by 100 and you get the percent abundance of boron 10 is 19. So what's the percent abundance of boron 11?
81.
81, because you just do a subtraction.
Okay.
Percent abundance of boron 11 is equal to 100 minus 19, which is 81. So that's how you do the work to find out the percentages. And remember how I said that we would pick this percentage because it seems the most reasonable.
Right.
And we actually calculated 19 and 81, which is pretty close to that.
Really close. Yeah.
So that quiz problem, you probably did not have to do any work. You had to just do some mental work and say, oh, the
was
atomic weight
both.
is closer to 11, so there's more 11. So I'm going to pick the answer that has more 11 percentage-wise.
There was one that was like that where it gave you the percentage kind of averages, or not average is not the right word, but the percentage range. No, not even that either. Those percentages.
Well,
And then there was another one that asked you a little bit more in depth.
yeah. So when you take a look at, you can retake those quizzes, you know.
Yeah.
And you may be able to see that at least in one of them, you don't really need to do any calculations. You need to just think about it a little bit.
Yeah.
Okay.
I noticed that. All
What
right.
else can I help you with?
Those were the only questions that I had at the moment, and I'm gonna do some studying and then some test taking.
Okay. Well, you can always call back in at 7 or 6, but you really want to start the
Okay.
exam by 9 because you get 3 hours to take the first part, and then you have to finish the second part in the next half hour. And you want to make sure that you're pretty good at taking photos and put them onto your computer and get them all in one folder. For part 2, that's the submission part. That's what's going to take people the most amount of time. Is you end the question part of the test. Immediately you take photos of your work, upload them to your computer, put them all in a file, and I want each photo labeled appropriately. So for problem 1, you would name that photo Acosta 1.
Okay.
And for problem 2, it would be Acosta 2. So in your folder, you should have 11 photos, Acosta 1 through Acosta 11, plus 2 more images, one of the front of your 3-inch by 5-inch card and one of the back.
Okay.
Now, of course, you should start the folder and put your note card images in there to begin with.
Mm-hmm.
And I think I asked you to name your note card images like Acosta Note 1 and Acosta Note 2.
Okay.
And I don't care which side is side 1 and which side is side 2.
We'll have a periodic table.
I put a periodic table in for every problem that I thought needed one. Okay. But when you look at the exam, you will see all 11 questions at the same time, and you can scroll up and down. So if there is a problem where you wanted a periodic table and it isn't listed, you can always scroll up and down and see one.
Okay.
But again, I put a periodic table down for every problem so that you wouldn't have to scroll up and down. It would be right there for you if you needed it.
Sounds good.
Okay.
All right. Thank you.
You bet. Thanks for calling in, because I always appreciate it when students do that. Now, I want you to turn your mic on and say goodbye to everybody.
Bye, everybody.
Bye, everybody.
Take
All right,
care.
Gabe, you take care.